Okay, now after this, so who will produce such rays of light? Next question comes. We have two things: primary source. So what do you mean by primary source? Which emits light of its own. Which emits light of its own. So these are called as the primary sources. What do you mean by primary source? Like example, sun, candle flame, Hallwick lamp, tungsten filament bulb. All these are examples of they'll emit light of their own. These are called primary sources. Next, we have secondary source, which does not emit light of its own. A good example is objects around us. So all these objects around us, they don't emit light. Suppose I am myself. Do I emit any light? No. So will I be visible in the pitch dark room? No, I'll not be visible. But can you treat me like a source? Yes. Because if the light emitted by the tube light will fall on my body and my body will reflect as if I feel like I'm a secondary source here. So which does not emit light of its own. Fine. Yeah. This is okay. Now after this, uh, ray of light. Once again, I'll come this one. So what do ray of light? What do you mean by ray of light? It's like a geometrical representation of the flow of light energy. Geometrical representation of, once again, I'm introducing flow of light energy. So what I do is like how to represent that ray of light. Very simple. Just I'll indicate this one by a straight line with an arrow. So what do that arrow indicates? Direction of propagation of light. To tell that the light is moving towards light, that arrow will indicate here. So what do you mean by that? The light is propagating this one. Okay, next again, after this, third one, we'll take the next condition. Beam of light. Bundle of rays. The bundle of rays are called as beam of light. So if I so some for more than two rays when you draw it, no, then this has to be considered like a beam of light, what we can call it as well. And the arrows will indicate the direction of propagation of beam of light. Again the beams, convergent beam. Look at the diameter of the beam. If the diameter of the beam decreases as it propagates, then it should be convergent beam. Here, look at the diameter here, it's more. So as it propagates, the diameter decreases. So therefore, it's said to be convergent beam. So what is the definition for convergent beam? The diameter of beam decreases as it propagates. Let me save it. Next, divergent beam of light. Divergent beam of light. So what do you mean by divergent beam of light? The diameter of beam decreases as light propagates. So this is called a divergent beam. Parallel beam of light. Okay, there's a good example. Beam of light, parallel beam of light. The diameter of the beam remains constant. Let me take the same diagram. Parallel beam of light. So here diameter remains constant. Diameter of beam remains constant as it propagates. So these are the very important terms we'll be often using in our this optics chapter. So divergent beam, convergent beam, parallel beam of light. Okay, after this one, next again, the object. So again, the source, the types of sources, I think the number will put it, the number 8. Sources will be point source of light. A good example is point source of light. So we represent by small LED bulb. A good example of this is light emitting diode. Small, tiny. I think that LED, what happened, we can approximate to be as light emitting. I think red, blue colors, what you can see, no, that nothing but called as a light emitting diodes. Sir, what do you mean by that? I think you can see on my screen some. So this dots are there, no, like this nowadays for decorations we use this LED bulbs. That one. So that LED is an approximate point source. No, not a point. Point source is an idealized one. What do you mean by point? We should not have any volume. So approximated point source, that one. This LEDs is one good example what we can take it. Okay, after this. Now, how to produce point source of light? LED, this one. Or else what I do is like, I'll take a cardboard, wooden box. I'll fit a tungsten filament bulb. This will be connected to the AC 230 volt. The bulb will start glowing. And what it does, it starts producing light energy. So let me make a small pinhole in it. Then what we notice is like practically we see that the light coming from that. So this pinhole is a point source of light. Pinhole is a point source of light. The pinhole will be like a point source of light. Getting the idea? This one. So these are the some ways methods of providing. Now we have extended source or anything. So we can take the tube light. Nowadays, we have plenty of examples. No? So from here, the light will be coming from all. So this is like an extended source. Okay, now let me introduce to the real object. 8, 9. Real object. So the incident beam. So if the incident light diverges from a point, diverges from a point, the point of divergence is location of real object. A good example, this LED bulb. So when you take this small tiny LED bulb and switch on, so what will happen to the light? The light, so look at the incident rays, they are diverging from a point. So definitely what it is like a, so that LED will become now a real object. Of course, it's a source. I'm calling it a real object here. Similar next virtual object. Virtual object. So what do you mean virtual? The if the incident light incident rays will call it, because we are dealing with a ray optics. No, if the incident rays converge at a point, the point of convergence is location of virtual object. So what shall I do is I'll take two laser beams, two laser guns. Okay, I'll trigger the gun. So then these two guns, they are going to produce the beams identical, monochrome identical. So now this particular location now where the two lights they converge, the point of convergence will become a virtual object. Okay, look at this. These are the incident rays. They're converging the point. So this will become a virtual object here. Okay, after this, we'll go for the real image.